Hey, what's up, guys? This is Sheng here. So today, let's take a look at today's daily challenge problem, number 1229, meeting scheduler, right? So this is another like interval problems, right? So this time you're given like two array of slots, where each slot represents an interval, in this term like a meeting duration, right? And our task is to return the earliest time slot that works for both of them, that is of duration, this duration. And if there's no common time slot that satisfies this requirement, we simply return like an empty array here. And here, it is guaranteed that no two available slots of the same person interacts with each other. So this one, what does it mean? It means that for each person, the the intervals can only be like this. So none of the two intervals will be overlapping with each other. So basically, there's no, for the same persons, there is no intervals that will be something like this. Basically, so the intervals, they're like they're occupying the unique time range. That's what it's saying here. Okay, but of course, slots 1 and slots 2, they'll definitely have like some intervals. Otherwise, there won't be any answer in this case, right? So, and then, for example, right, we have slots 1 and slots 2 here, and in this case, we have these 3 slots meeting interval, and we have another 2 slots for person 2, and the duration is 8. So we have 1050, right, and then we have 60 120, and then we have 140, and then 210, right? So below we have 10 to 15, right? Sorry, 0 to 15. 0 to 15. And then the next one is 60 to 70. Is like this. Right? So how many intersections we have here, right? So obviously we have 2 intersections here. The first one is this one, from 10 to 15. Second one is from 60 to 70, right? And since our duration is 8, so this one is smaller than this one is only 5. That's why this one is not a valid answer, but this one is. That's why we return 60 to 8 to 68, right? That's gonna be the first durations, the intersection, right? We get. And obviously, so in example 2 here, if there's no valid uh, overlapping durations, we simply return like empty. Okay, so here are some like basic constraints, right? So obviously, for this kind of intervals problem, we always need to sort, right? Because we want to do a line sweeping, and then we have like, we either sort by the starting time or by the ending time. But in this case, it doesn't really matter to sort either by starting time or ending time, because for each person, there's no overlapping. So we can, that's why, the if we sort by the start time, the ending time will always be sorted. It will also be sorted, right? So after sorting these 2 slots, how can we find the intervals, right? Mm, so what's going to be the criterion for us to basically to move to to move this either the first person's or the second person's uh, interval forward, right? So for example, we have this kind of, we cannot move by the starting time. And why is that? Because let's say we have this one. we have this interval. This is start and end, right? So here we have a start and then we have another start and then we have another start end, right? So as you guys can see, even though let's say we start from the starting time, they have the same starting time, since the ending time, this the first person has a bigger ending time. That's why once we compare these two in overlapping, if this one doesn't satisfy our conditions, right? So basically our approach will be, if this one doesn't satisfy the conditions, we have to find a way to either move the slots 1 forward or we move the slots 2 forward, right? That's how we keep going forward until we find the first available one, right? But like I said, so how should we move, right? Like we cannot use the starting time. Instead, we should use the ending time, right? So in this case, um, basically we compare the current first slots, the first person slot with the second person slot ending time, and we move forward the person who has a smaller ending time. In this case, it's the second one, right? And then so once we and then we move this one, we move this the second person forward to this kind of interval, right? And then we compare this one with this one, with, and then keep going. Once we let's say for the third one, the third one is something like this. Okay. So after comparing the third one with this first with the person slots ones in interval, now the as you guys can see, we should move the slots forward. We should move the slots 1 forward because it doesn't make sense, right, to move, because this ending time is smaller than this one. That's why we have to move this one forward to somewhere here. And there are like some edge cases. For example, if this one has like a very big, there could be different cases, right? So for example, if the first one is something like this, we have this one, and then the second one is starting from here, right? So at the beginning we have this two, right? And then same thing, right? Basically we compare the ending time. So since this one is smaller than this one, that's why we keep moving the forward with the smaller ending time, right? And so once we okay, so and then how can we find the intervals, right? So for the intervals, we have kind of like trick. We can always do the maximum, sorry, the minimum, right? The minimum of the ending 1 and ending 2 minus the maximum of the start 1 and start 2. So basically this is the trick, right? To calculate the overlapping section for two intervals. If there's no intervals, obviously this one will return like a negative value, 0 something, 0.5. So that I think we can simply just use this one formula to compare the intervals with the duration, because duration is always positive numbers, right? So if there's no overlapping at all, obviously this one will give us like negative, and negative will never satisfy its duration. That's why we can use this one to check all the pairs. Okay, so once we figure that out, the coding should be pretty straightforward. So like I said, we sort those two slots first, right? Slots 1, slots 2, sort. And then we have n1 going to be the length of the slots 1, and n2 going to be the length of slots 2, right? And then we need 2 pointers. So we have I and j starting from 0, right? And then while I is smaller than n1 and j is smaller than n2, okay? So for each of the two intervals, we s1 e1 equals to the slots of I, right? And then we s2 e2 equals to slots of j. So we calculate, right? Intersect, right? Of two slots, right? So it's going to be if the minimum of e1 e2 minus max of s1 s2, right? If this one is equal either greater than duration, right, then we know we find the answer, right? We simply return. So what's going to be the answer? So the minimum e1 and e2, that's the ending point of the intersect, and this one is starting point, right? And we simply return the starting point and starting point plus the duration, right? That's how we get this 60 and 68. So which means this one is 60 and this one is like 68. Okay. Otherwise, like I said, so if e1 is either equal greater than e2, right, then we just move the second one forward. Otherwise, we move the first one, the first slots forward by 1. Okay. And in the end, if we didn't find anything, return the empty. Okay. Yep. I think that's it, right? So here we move who has smaller ending time, right? Run the code, slots. Okay, accept it. Yeah. So that's it, right? So time and space complexity, right? I mean, it's pretty straightforward. It's n log n, right? Yeah, if you really want to get this one for very detail, let's say we have m and n, right? M and n length, so we have what? We have n log n plus m log m, right? So how about this one? Here's like m plus n, right? Yeah, obviously this one takes precedence because this one is like has a higher runtime, right? Yeah, so that's it for this problem. It's another little bit of variation of the interval problems, and I'll just stop here. Yeah, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.